Hello everyone, I welcome you all. Today we are going to study about projection in which types of parallel projection. So let's start. Topics that we're going to cover in the PPT presentation will be introduction to projection, classification of projections, parallel projection overview, types of parallel projection, applications, comparison with perspective projection, and then at last summary and references. So let's start with introduction to projection. What does projection means? We can say that representing an n-dimensional object into an n1 dimension is known as projection. Here we also have the detailed definition of what projection is. So it is the process of converting a three-dimensional object into a two-dimensional object. We represent a three-dimensional object on a 2D plane as x, y, z coordinates representing x, y. When these geometric objects are formed by the intersection of lines with the plane is called as the projection plane and the lines are called as the projections. Projection is broadly classified into two types, parallel projection and perspective projection. Here we have a broader view of how the classification of projection is done. Parallel projection and perspective projection. Parallel projection includes orthographic and oblique. Orthographic projection is subdivided into principal views and axonometric, and oblique is subdivided into cavalier and cabinet. Perspective is divided into three parts: 1 point, 2 point, 3 point. In this whole presentation, we are going to study about parallel projection in detail. Let's start. What is parallel projection? Parallel projection is a specific type of projection. In this projection method, the projecting lines come out parallel from the object surface. These lines then hit the projection plane in a parallel manner. That's why it is known as parallel projection. Here is the representation diagram of how parallel projection is being done. What are the key features of parallel projection? First, the center of projection is at infinity. Second, the view of the object on the plane is less realistic. Third, there is no foreshortening effect. And the fourth, the relative dimensions of the object are preserved. So these are the key features of parallel projection that we will have to keep in mind. Now, these types of parallel projection is subdivided into two other main categories: orthographic projection and oblique projection. Orthographic projection. It is a type of parallel projection. In this, the projecting lines come out parallel from the object surface. These lines then hit the projection plane at the right angle, that is 90 degrees. Here is the 3D object effect and 2D orthographic projection effect of the picture. Types of orthographic projection. Orthographic projection is further subdivided into two categories. First, multi-view projection and second, axonometric projection. Multi-view projection. This gives us different views of the object. It has three main types: top view, side view, and front view. Top view, this shows that the object is seen from above. Side view shows the object is seen from the side, and front view shows the object is seen from the front. And axonometric projection. It is a type of orthographic projection in which the projection lines are perpendicular to the projection plane. Object is rotated around one or more of its axis. This rotation allows us to see multiple sides of the object. Next is oblique projection. Oblique projection, it is the second main type of parallel projection. In this method, projecting line comes out parallel from the object surface. However, they hit the projection plane at an angle other than 90 degree. But in parallel projection, it hits from out at the 90 degree. Here is the diagrammatical view of how oblique projection is being done. Types of oblique projection. Oblique projection has two main types: cavalier projection and cabinet projection. Cavalier projection, the projecting lines hit the plane at a 45-degree angle, and in cabinet projection, the projecting lines hit the plane at a 63.4-degree angle. What are the applications of parallel projection? It has several uses in computer graphics, technical drawings, computer-aided designs, maps, user interfaces, and much more. Advantages of parallel projection. Number 1. Preserves measurements. It keeps the relative size of the objects intact. Second, simplicity. It is easier to implement than perspective projection. Third, accuracy. It is useful for technical drawings where exact measurements are important. Limitations of parallel projection. Less realistic. The images don't look as realistic as those created with the perspective projection. No depth perception. It doesn't show depth as well as perspective projection. At last, we can conclude our presentation with that parallel projection includes orthographic and oblique projections. Each type has its own purpose and advantages, and this type of projections are widely used in engineering and CAD environments. This is the reference that we have used to make our presentation.